Hi, this is Mrs. Barr. Today we're going to do a quick lesson on stoichiometry. It's a very complicated word. It sounds intimidating, but I promise it is nothing unlike other things that we've already learned in chemistry. So it's all good. Stoichiometry is what we're focusing on today. Okay, so the basics of stoichiometry is actually very similar to dimensional analysis, which we talked about last semester, if you can remember back that far. But dimensional analysis is also just called unit conversions. Unit conversions. It's exactly like it sounds. We are converting from one unit to another unit. So that unit could be feet. That unit could be seconds. It could be paws on a dog. Any unit we're going to use to convert from one to the other. So basically what we learned last semester, just as a quick refresher, I'll give you an example of that, and then we'll move into the new stuff of stoichiometry. Okay, so the example that I'm going to use today is converting from feet to inches. Pretty simple. I think we can all handle it. Okay, so the first thing we need to think about is how many inches are in 1 foot? Basic question. I expect that you all already know this answer, but we should know that there are 12 inches in 1 foot. So I'm going to write that up here, that in 1 foot, that is equivalent to 12 inches. Very simple way to write that. 1 foot equals 12 inches. What we learned last semester is that instead of writing them as equal to each other, I can use them as unit conversions if I turn them into a fraction. So there are two fractions that you can get out of every pair that equal each other. So the first one we're going to do is we are going to put 1 foot over 12 inches. Just like this. That's my first unit conversion. And then for the second one, we are going to flip it. So this one's going to be 12 inches over 1 foot. So this might seem kind of silly to write the same thing twice, but the reason we need both conversions is because sometimes we might need to convert from feet to inches, and other times we might need to convert from inches to feet. So it's important to know that these can go both ways. We can flip-flop them if we need to. Okay, so for example, let's just say that somebody was asking us to go buy 3 feet of ribbon. All right, so we want 3 feet. But the problem is when you get to the store and you're picking out your ribbon, they only measure them in inches. So we need to figure out how many inches 3 feet is. All right, so my first step for doing this is to take the number that they give me and put it on top as my numerator in the first fraction. So what I like to do is I like to put that 3 feet over 1, just the number 1. It's not 1 foot, it's not 1 inch, it's just 1. It's purely a placeholder. It's there to remind me that my 3 feet is the numerator and that it is multiplied with the top group. If you don't like this 1, if it confuses you, if you look at that 1 and think that it needs to be labeled with something, that's okay. You don't have to write it. I like it, so I'm going to use it. But if you prefer to just write 3 feet and leave it, that is completely fine. All right, so for this example, I am trying to convert to inches. I'm starting with 3 feet on top. And remember with our basic division rules that anytime something is on top and bottom, they're going to cancel each other out. So in order to get rid of this feet, I am actually going to find the unit conversion with feet on the bottom. So in this case, that's this guy right here. That is the unit conversion that I am going to use for this example. So I have my 3 feet. I'm going to multiply that by 12 inches over 1 foot. And when I multiply across, I should get the answer I'm looking for. Since I have 2 1s on the bottom, I really don't have to worry about my denominators. So I am just going to multiply 3 times 12 to get my answer. Most of you should be able to do that in your head. So that should come out to be 36 inches. How do we know that it's inches instead of feet when we get this answer? Well, we just talked about how if something is on top and bottom, it's going to cancel out. So since I have feet on top in my numerator for the first one and on the bottom for the second one, I can cross those out. And all I'm left with is this inches right here. So that inches is the unit that carries over to my answer, 36 inches. All right, so stoichiometry is basically the exact same thing. The only difference is now we are adding moles. You've learned what a mole is. You know that it's just a number. It's an amount. It is a really big amount, but it's just a number. It's 6.02 times 10 to the 23rd particles per 1 mole. So using that, we can use stoichiometry to convert from a mass to the amount of moles. Or we can convert from moles to the volume of a gas. This is all stuff that scientists use all the time. We need to convert back and forth from one substance to another all the time. So this is the basics of stoichiometry. The first thing we are going to do is we're going to talk about how to convert from moles to particles. So our first example I'm going to give you is, let's just say we have, 5 moles of nitrogen gas. Now remember, nitrogen gas is a diatomic molecule. I'm going to put a separation here so you can see that that's separate. Now we're talking about stoichiometry. So nitrogen gas is a diatomic molecule, so it always exists with a partner. That's why I wrote N2 instead of N. Okay, so let's say we have 5 moles of N2, and I want to figure out how many molecules of N2 I actually have. Sorry, I'm trying to adjust my light here. All right, so I'm trying to convert this 5 moles of N2 to molecules using our 6.022 times 10 to the 23rd, also known as Avogadro's number. So in this case, my unit conversion is going to be the number of molecules in 1 mole. So, like we said, that's Avogadro's number. There are 6.02 times 10 to the 23rd atoms or particles in 1 mole. Oops, wrong direction. 6.02 times 10 to the 23rd particles in 1 mole. I could also write this the opposite direction if I need to use it the other way. So I could also say 1 mole over 6.02 times 10 to the 23rd particles. Whichever way I need to use it, I can flip it. It's all good. Okay, so the thing I'm going to start with is the number that they gave me, or I gave you. So it's this 5 moles of N2. Again, I'm going to put that number over 1. Just a placeholder. You don't need to use the 1. I like the 1. All right, and since my moles is on top here, in order to cancel that out, I need to have that on the bottom. So I am actually going to use this conversion that I wrote up here because moles is on the bottom and I need moles to cancel out. All right, so over here I have 5 moles over 1 times my 6.02 times 10 to the 23rd atoms over 1 mole. Now, we just talked about if you have a unit on top and bottom, it's going to cancel out. So here, I can go ahead and cancel out my moles, and I'm going to be left with atoms, or in this case, molecules. So if I multiply these together, we'll be able to find that. So let me show you, let me flip my screen so you can see my calculator real quick. All right, so here is my calculator. I'm going to plug in the numbers that I got for my answer. So I'm just going to take my 5 times 6.02. This EE button is common on all calculators if it's a nice calculator that actually has all the buttons you need. This EE represents times 10 to the. So after I push EE, I can simply push 23 equals 3.01 times 10 to the 24th. So that total is my number of molecules of nitrogen gas. Let's see if I can flip my screen back. There we go. So my answer for this one is going to be 3.01 times 10 to the 24th molecules. That seems like a huge, huge number, and it is, but remember these molecules are super duper tiny, so that's fine. Okay, the second way we can use stoichiometry is to convert from moles to mass using something called the molar mass, which you should be able to find on your periodic table because we have already talked about this. So for this example, let's find the number of moles in, let's say, 60 grams of this N2 gas that we are currently talking about. So if I have 60 grams of N2, and I want to convert that to moles, I'm going to use something called the molar mass. Okay, so I need to figure out how many grams of N2 are in 1 mole. And to do that, we can just look at our periodic table. So here is mine, right here. You can see my nitrogen is right up here. It's number 7. And the molar mass of one nitrogen atom is 14.007. We'll round that to 14.01 grams per mole. But remember, it's not just nitrogen, it's nitrogen N2. So I need to take this number times 2. So my molar mass is actually going to be 28.02. So I'm going to write that as my unit conversion, 28.02 grams in 1 mole. Or the other way, we could write 1 mole over 28.02 grams. Those are the unit conversions for this one. All right, so I'm going to start with the number they give me. I'm going to take this 60 grams of N2, put it over 1 as my placeholder, optional step. And I'm going to take this times whichever one of these two unit conversions will cancel out my grams. So grams is on top here, and I want grams on the bottom in my unit conversion. So I'm going to use this guy right here. So I'm going to take this one times 1 mole over 28.02 grams. And when I divide this out, since this is top and this is bottom, we are dividing this, I should be able to figure out how many moles I have because these grams will cancel each other out. All right, so let's pull out my calculator again. Here we go. We need to take 60 grams divided by our molar mass of N2, which is 28.02. And we should end up with 2.14 grams. So my total answer here is going to be 2.14 grams. Oh, sorry, not grams. We canceled out grams. 2.14 moles of N2 for my final answer. So that's the basics of stoichiometry. We will take it several steps further, but you have a general introduction. It's just unit conversions, and it's just moles that we've been talking about all chapter. Let me know if you have any questions, and I'll see you tomorrow.